What's up, everybody? It's Dr. J. It's right before the holidays, and I'm rocking a beard. Okay, that's the beard. That's what's up. On the real, I just didn't feel like shaving. I was tired and I was cold, and I said to myself, that beard, you know what it is? It's the kind of thing that keeps you warm. And so that's what's up. All right. So today we're going to talk about completing our lab reports for the energy lab. Okay. So right here, we've got our energy lab data. And this is data that I stole from someone. I won't mention whom. I want to put anybody on blast, but I stole this. So if I stole this from you, it's because you did a good job. And so I felt like stealing your data because it was going to be easier than collecting my own data. Good job. Thank you. I stole this, correct. Okay, so what you guys are going to do with this is you're going to make a graph. Okay, so this is what the graph's going to look like. So this is where we're going, right? Let me delete the graph so I can then show you how to make the graph. Delete. Okay, so here's what you want to do. You want to select these guys, okay? And then you got to hit the control button on your keyboard, and you got to select drop time and max height. You keep control, then you hit control again, and you click on this potential energy, okay? Those are the things you want. And then you go to insert chart, okay? You insert the chart here, and it's going to give you the stacked column chart that you don't want. And so what you do want is a column chart, a regular column chart. Boom, that's what's up. And then you're in good shape. Okay, so you got your column chart. That's exactly what you want in your life. And so this column chart, oh, this is interesting. Okay, so it shows you a nice progression, and I'll go ahead and use little stylus here, do some annotation. Okay, so basically it shows you that every single time drop time, and I'll use, yeah, blue is fine, drop time falls, okay? It gets a little smaller every single time. Additionally, okay, so this is the drop time in blue. The max height, that's going to fall. So max height falls each time, okay? And then maximum potential energy, that falls each time your golf ball bounces on the ground. I'm just scratching something off of my computer, so it's picking up my thumb, and then now it's fixed, okay. So the reason these things all fall so nicely together is that actually max height and potential energy are the result of calculations done with only the drop time, okay? So this is mathematically producing these guys, hence, right, the clear trend across all three. But it is also true that trend is real, okay? And so we're going to look at these all three together so that we can understand that they have a relationship, okay? Drop time, max height, and potential energy are all related, okay? And they all do indicate to us very clearly that the golf ball loses energy each time it impacts the ground, okay? It's not a perfect 100% efficiency bounce, okay? So now I'm gonna clear that and get back to the data. Okay, so you've already collected these data. So all you have to do at this point is just copy your data, okay, and paste them into your lab reports. Let's go to the guiding questions. So we've gotten all the way through the introduction, okay? We've gotten all the way through the introduction as well as the materials and methods, and now we're on the results, all right? So first order of business, copy and paste your data table. Then you copy and paste your graph, okay? So the video instructions were for you to make the graph. Now you go over here to the graph, right? You copy Control C, right? And then you Control V, right? And you can paste it linked or unlinked, whatever you want, probably linked. And you paste it in, but I'm not pasting it, okay? So next, I'm helping you with two really good sentence starters, okay? So first, over the course of each successive drop, that is bounce, did drop time, max height, and max potential energy all increase or decrease, okay? So all you have to do is adjust this sentence. Over the course of each bounce, drop time, max height, and max potential energy all decreased, all right? And so note, if these values did not all decrease over the course of each drop, you better see me, please, to discuss recollecting data because something is wrong, okay? Something went wrong somewhere, somehow, we need to talk about it, all right? That's the deal. Next order of business. Please report your energy efficiency values using this sentence template, okay? So it's ready to go. my first bounce had an energy efficiency of, and my second bounce had an energy efficiency of, okay, and what were those energy efficiencies? They're right in your table, right? So for this data that I've so conveniently stolen, my first bounce had an energy efficiency of 68.62, and percent in my second bounce had an energy efficiency of 73.337%. Okay, if you want to round those to 69% and 73%, that's totally fine, okay? All right, so, but you have to use your data, not the data that I stole, okay? I get to steal, you do not, okay? That's what's up. So now back to the lab report. All right, so now we're on the discussion here. So each time the ball bounced, did the ball gain or lose energy? Okay, you should know the answer to that question, right? And how do you know? So you've got to reference both your graph and your energy efficiency values. Like you could say, I know that the ball lost energy because according to the graph, right, the amount of energy went down with each successive bounce or drop, right? Also, my energy efficiency values, right? They were less than 100%, okay? So that indicates that energy was lost, all right? According to your data, which bounce was more energy efficient, the first bounce or the second bounce? And that just you know has to do with your data. In my case, right, with these stolen data, the second bounce was more efficient because it was higher. 73% is higher than 69%. Okay, your data may differ from mine, right? So you're just making it, you're just you know including your result there basically. Okay, but you're comparing the two, which is a little different than straight reporting. And then what do you think this result means? Okay, so in my case, I guess it means that the second bounce was a little more efficient because I guess the ball just has a harder time retaining a lot of energy. So when it doesn't have as much energy, it can retain that energy more efficiently. That's the way I would look at it. But you know, you can make your own interpretation and speculation. How do you think the quality of your data could have been improved? Were there any experimental / procedural errors that might have affected the accuracy of your results? So whenever I tried this on my own, I tried with my little like phone, you know, using my phone and the timer on my phone. And I almost feel like that's not the most accurate timing, right? So I really think that accuracy always comes down to timing whenever we're using our stopwatch or our phone. But again, if you saw that there might have been other errors, like maybe you're dropping the ball too high one time and too low another time, or who knows what it was, right? You know, you've got to go ahead and list those, okay? And then that's it. All right. So it should be a pretty straightforward assignment for today. All right. And good luck. Okay. As always, good luck, and may all the forces be with you.